Hello everyone, welcome back to Rust Planet. In today's video, we are diving into the fascinating world of Rust and C++ interoperability part 2. If you haven't watched the initial part, make sure to check it out as it provides a great overview of what we are exploring today. Let's kick things off with callbacks from Rust to C++. In the following example, we have Rust code on one side and C++ code on the other. The Rust code defines a callback function which takes a function pointer as an argument and invokes it with the value 42. If I go through the code, here you can see the use statements which are helped to import the modules which are necessary for working with strings and raw C types. And then the type callback extensive this statement, this line, the third line, defines a type alias from a C style function pointer. The function callback takes a callback function as an argument and calls it with the value 42. And then the function getGreeting returns a dynamically allocated C string containing hello from Rust. The free string releases the memory allocated for the C string. And then if we go into the C code, we define a function call from Rust, which will help us to demonstrate how to pass the callback from C++ to Rust. We also exchange strings between two languages here. So if I go through the C++ code, here you can see something called typedef void callback defines a type alias from a C++ function pointer. The callback from Rust is a C++ function that prints the received value from Rust. In main function, the callback invokes the Rust callback and getGreeting retrieves and prints the greeting string from the Rust. The free string is called to free the memory allocated for the Rust string. If we were running it, so initially cargo build space hyphen. Sorry. Yeah. So here we got the output. So we have done with the example of callback from Rust. And then diving into the next example, let me open it. Let me close the existing tabs so that it's easy for us. Yeah. Here we explore how Rust and C++ handle structures and complex data structures. So here we have a simple point struct defined in both the languages, and the Rust code provides a function that calculates the distance between the 2 points. We then call the function from our C++ code, showcasing seamless interoperability with complex data structures. If I go through the code, um, here calculate distance computes the Euclidean distance between 2 points, as we can see here. Wait. Yes. This calculates a Euclidean distance and then it returns the output. So in the C++ code, in the C++ code, I'm very sorry, I've showed the wrong one. In this code, we are calculating the Euclidean distance. So in the C++ code, the point struct matches the layout of the Rust point. The function calculate distance is called into the is called to find the distance between the 2 points. So if we run the code, yeah, and so I think how to run it, maybe you need to go through the part 1 video so that you understand it well to how to run and all. I'm very sorry for confusing myself and confusing you guys, but yeah, bear me for a sec. So yes, now we can see the distance between the 2 points is 5. It's technically the Euclidean distance. And then now let's get into the next example. Yeah, this example takes us into the realm of asynchronous interoperability. Thus, asynchronous capabilities meet C++ as we demonstrate an asynchronous operation in Rust and handle the result in C++. The Rust code uses features to simulate an asynchronous operation, and the C++ code waits for the result, showcasing a smooth integration of asynchronous functionality between the two languages. If we go into the code understanding, here you can see we have defined a simple asynchronous structure called myFuture that sleeps for 2 seconds and then resolves to 42. The run async operation function starts an asynchronous operation and called a provided callbacks with the Rust. If we go through the C++ code, here you can see handle async result is a C++ callback function that prints the result of the asynchronous operation. And then this run async operation is called to initiate the asynchronous operation from Rust. And here you can see this line is used to allow the operation to complete. Let me run it. I forgot to mention this thing. We also need to update our toml file for every package we have created. So here we used this futures crate, so we have imported that in the toml file. Let us run it. And so now, yeah, we got the result after a 2 seconds delay. Now, if we go to the next code, let me close this tabs and this example takes us to the concept called generics, where generics play a crucial role in writing flexible and also the reusable code. In this example, we delve into how Rust handles generics and how C++ can interact with Rust generic functions. We define a generic add function in Rust that can work with various types, and we call this function from our C++ code, demonstrating the power of generics in cross language scenarios. So if you see the code, we have like add functions. So sorry. So add is a generic Rust function that takes two arguments of the same type and returns the sum of it. Um, so this no mangle is an attribute. You might get a doubt what this line is for. So it ensures that the function is accessible from C or C++. You can use this same attribute if you were doing interoperability between C language also. And if we go to the C++ understanding of the code, as you can see, let me, yeah. So here add is a C++ template function that matches the generic Rust function. The function is instantiated for both integer and double types, demonstrating generic interoperability. So now if we run it, yes, here we can see the output of what we have been executed. Now, if I go into the next code, we go into the other realm, which is also important and plays a crucial role in Rust. That is traits. Uh, so traits in Rust are like similar to interfaces in other languages, where I can say where we use it for providing a way to define the sharing behavior. In this example, we have a Rust trait called shape, along with the structure circle, uh, where we uh, where we implement this trait. So the C++ code calls into Rust to calculate the area of the circle, showcasing how traits contribute to a clean and modular design across language boundaries. So if we go through the understanding of this code, like let's go to the Rust part, and then here we can see a shape, which is a Rust trait, where it is a defining method area for calculating the area of shape. So circle is a structure implementing the shape trait with the method to compute the area, as we can see here. And then the circle area is an external function providing C accessible interface to calculate the area of the circle. And then if we go to the understanding of the C++ code, here circle in C++ matches the layout of the Rust circle, as we can see here. And then circle area is called to calculate and print the area of the circle. Now let us run this example to see whether we get the proper output or not. Yeah, sorry. Yeah, here we can see the circle area. And then let's go into our last example. Um, yeah, here is this libdoraras. I will just drag you out when I'm going through this. see main file explanation. So in the last example, we explore how Rust can leverage external crates. We use the random crate. So let me show you the toml file also. So here we use a random crate to generate a random number in Rust, and then we call this Rust function from our C++ code. This demonstrates the seamless integration of external Rust libraries into C++ project, which highlights the interoperability capabilities of Rust. So if I go through the Rust code, so here you can see a function called generate random number, which utilizes the external Rust crate rand, which is nothing but a random number, to generate a random number. So if I go through the C++ code, yeah, this generate random number function is called from C++, showcasing the ability to use to use external Rust crates seamlessly. So if we run it, yeah, now we can see the random number which is generated. So every time we see the random number which is generating being different. Yeah, and there you have it. It's a journey through Rust and C++ interoperability. I hope this video has provided valuable insights into how these two powerful languages can work together seamlessly. If you have any questions or topics you would like us to cover in future videos, feel free to leave us a comment. Um, don't forget to like, share, and subscribe, and hit the bell icon for more content. Until next time, happy coding. Thank you.